So welcome everyone to this next lecture of the Internet Ecosystem and Evolution subject. In this lecture we are going to conclude our earlier lectures on BGP interdomain routing. Just recall that in the previous lectures we discussed and introduced the simple service model to reason about the large-scale structure of the internet, the AS level topology, and then we introduced the notion of value-free routing, which is basically the synthesis of all the economic rules and the economic incentives of autonomous systems that are the actual stakeholders in the internet interdomain routing system into a very simple set of rules that govern the way traffic flows across the AS level topology of the internet. So in the first part of the lecture we are going to just recall very shortly the service model and the notion of value-free routing, and of course we discuss the way we configure the value-free routing rules in the BGP routers. And the first part of the lecture, the new material, will cover various ramifications and specializations on top of the basic value-free routing policy. Namely, we are going to configure, we are going to learn the way to configure BGP for actually also adhering to the preferred customer rule on top of value-free routing, and on top of the preferred customer rule we are going to also apply the shortest ASPS routing policy to arrive to an actual routing configuration, which will then basically we conclude that will give a very good basic understanding of how actual BGP routers out there in the internet, operational BGP routers out there in the internet are configured. And the second part of the lecture will be devoted to discuss further advanced BGP policy routing issues. Namely, we are going to discuss prefix hijacking and the ways to remedy or to mitigate prefix hijacking attacks, how to configure prefix filtering rules in BGP routers, filtering AS level passes, backup routing and AS pass prepending, hot potato routing and traffic engineering. In this preliminary slide I would like to stress that the material that is covered in this lecture will constitute the major part of the material that we are going to ask you to reproduce during the oral exams. So most of the time during the oral exams you will have to learn, you will have to solve simple tasks related to configure these advanced BGP routing policies in your GNS3 topologies. So I would like to remind you students to make yourself very familiar with the theoretical and the practical material that is presented in this series of 3 lectures. But first, let's just take a step back and recall the service model and the value-free routing policy. So the big idea was to actually we tried to understand or look into this common case definition of the internet as the internet is a network of networks. We identify the autonomous systems as the particular subnetworks that make up the internet, and then we went on and tried to understand the AS level topology of the internet. So we tried to understand when it is the case that 2 autonomous systems decide to connect their networks with an actual physical links, and we've seen that there is in order to reason about these types of AS links, we have to diverge from the actual technical details of building the internet, and we have to take a bit of an excursion into the area of economics, because the AS level topology of the internet is governed by these economical rules. Namely, there are the types of business relationships that can exist between 2 autonomous systems is the main reason why autonomous systems may connect their networks. So we've seen that there are these two simple types of AS-AS business relationships: the transit and the peer relationship, whereby in the transit relationship, a provider provides wholesale internet access to a customer autonomous system for a monthly fee, while in the peer business AS-AS business relationship, two autonomous systems that have a significant amount of symmetric traffic demands between one another decide to exchange this symmetric traffic on an actual physical link in order to save on the transit fees. So we from that point we concentrated on just these transit and peer relationships, and then we try to turn this economic understanding of the AS level topology into an understanding of the structure of the routes and the AS level passes, forwarding passes that emerge on top of this economic model. We've seen that traffic flows along the cheapest AS level pass, and this brought us to the notion of feasible and prohibited passes, and ultimately to this notion of value-free routing, where we've seen that the actual AS level passes that make sort of economic sense in this context are such that they do not form in the transit hierarchy of the internet. So a value-free pass actually goes all the way up in the transit hierarchy from customers to providers, until with at most one horizontal step we can go down in the transit hierarchy from from providers to customers to ultimately reach our endpoint, as long as a pass adheres to this very simple and somewhat informal rule. Then this qualifies as a value-free pass. Otherwise, it contains these sorts of values which are type of sub-passes which do not make economic sense, because in this case, for instance, AS4 is not interested to provide transit service to two of its transit providers. We've seen that value-free routing is just a model for us. So it is a good way for us to actually reason about passes, AS level passes that emerge on the internet, but this is not something that we can program into BGP routers, not the least of it because the BGP is not aware of the AS level topology of the internet. Neither it knows the type of labels that go to the AS level links, like this provider and customer or peer links. So this is not something that we can program into BGP proper. We need to find another way to encode value-free routing rules into BGP, so that the types of passes that BGP will distribute between BGP routers will all be value-free. And we've seen that the way we do that is through import and export filters. So this was the basic understanding. Whenever we have an autonomous system, the BGP rib of the autonomous system will have different sorts of advertisements that come from providers, from customers. So in this case, for instance, we have an advertisement whereby a customer advertises or announces an AS level pass to this to our autonomous system, which recall means that the customer has a pass to a distinct or a remote autonomous system and an IP prefix in this autonomous system. And now the customer wants us to be aware that it is willing to route traffic from our autonomous system to this remote AS. In this case, it generates a BGP announcement, which recalls by this reverse rule actually means that if we accept this BGP announcement, it will mean that our autonomous system will also have an AS level pass to this remote autonomous system through the customer autonomous system. So these types of announcements that come from customers in this very simple figure will be denoted by these little squares. Then we also have peer BGP announcements which come from our peers, and we also have provider announcements where a provider actually wants us to know that it is willing to route our traffic to a remote IP prefix. So this is the type of BGP RIB that we have in our autonomous system. And then wherever we have all the announcements tagged by a simple label that describes which is the type of AS business relationship through which we receive this announcement. This is a very simple rule we have to just follow. To customers, we export all types of announcements with all types of labels, be that customer, peer, or provider passes, because we want customers to be able to route along any type of these passes. The difficult part is through peers. So whenever we have a BGP announcement from a peer, which means that we have a pass during thanks to the reverse logics of BGP announcements through the peer to a remote autonomous system, we will not re-announce these types of peer passes to other peers, because if the peer accepted this pass, this would actually mean a non-valley free pass, which would take the succession of two peer-peer links in this case, and this would not make for our autonomous system economic sense to actually provide transit service to two of our peers. So the simple rules is that whenever we have a peer pass or a provider pass, we do not re-announce these passes to peers or providers, because this would be a violation of the valley free routing rule, and it would not make economic sense to our autonomous system to provide these sorts of services to its neighbors. So how to actually configure these rules into BGP? The idea is very simple. Recall that BGP routers work the following way. BGP routers generate these sorts of BGP announcements, which is basically a collection of a prefix encoded into the network layer reachability information data structure, and the sort of related attributes. We've seen that the important attributes are the ESPass attribute, the NextHop attribute, the local preference attribute, and the BGP communities attribute. We're going to just see again in this lecture how these attributes work to come up with a consistent BGP routing configurations. And then the receiver announcements go through import filters in BGP, go to the BGP RIB, the BGP best pass selection process, which is a fixed process. We'll choose an active pass from this BGP RIB, which will then be downloaded into the FIB, the forwarding information base, based on which the router will actually be able to route or forward packets along this path. Recall that the BGP best path selection process, the next slide will give a little bit more detail on this, but the big idea is that the destinations in the best path selection process are actual each IP prefix announced on the interdomain routing system. We prefer announcements first with the highest local preference rule, and only whenever there are multiple announcements with the same local preference, then we use the pass lengths of the ES level passes as a tiebreaker. Okay, and then active passes, and recall only active passes, so not all passes in the RIB, only active passes are advised to the neighbors, but this is again subject to export filtering. So wherever we have import filters and export filters, we can use these to withhold or rewrite BGP announcements. A little bit more detail about the BGP best path selection process. This is not here for you to actually learn. This is for here to actually for everyone to at least once in their lifetime see how the best path selection process works, because this is really inherent to BGP. The big idea is again that first the first decider is the local preference. Only when local preferences are equal, we go to the ES pass length attribute. If the ES pass length is also equal, then we go to the multi-exit discriminator. So the smallest multi-exit discriminator attribute value will be used as a tiebreaker. What's actually this MED BGP attribute will be made clear later on, etc., etc., etc. And this brings us to the configuration of valley free routing on BGP. Recall that this was a very important slide from the last lecture. The idea was that if we go back to this little figure, we've seen that we actually have two rules. We actually just, as BGP operators, we have two duties or two tasks to reach this behavior that is described in this figure. First, we have to configure import filters that will tag all the announcements that we received from our neighbors with the type of AS business relationship of the particular neighbor that communicated these BGP announcements to us. So we have to associate these tags with the BGP announcements we received from our neighbors. Of course, we are going to do that on import filters. And the second thing that we have to do is that wherever we have an announcement from a provider or a peer, then we have to just drop these announcements towards on BGP sessions in the export directions towards providers and peers, and only customers will receive these types of announcements. Of course, while tagging can be done on import filters, actual dropping of the announcements will be made on export filters. And this is the our diagram which describes this logic. So wherever we have an announcement from a provider, we're going to just associate the BGP community 300 with it. Wherever we have an announcement received from a peer, we apply an import filtering rule that will associate the BGP community 200 with it. And wherever we have a customer announcement, the customer announcements will have the BGP community 100 associated with it. Best path selection process goes on, and then we go to the we get just one active path. So recall that the best path selection process chooses one active path. We have the option to re-announce this active path to providers, peers, and customers. And the way we do that is that we re-announce everything to customers. We re-announce only customer routes to peers and providers, but drop everything that we receive from peers or providers, because, for instance, these types of passes or announcements which will lead to these types of passes will be a violation of the very free routing rules.